Okay, we are now into section 3.2, the derivative as a function. Really, there's not a lot new in this section, at least as far as the calculus, because what we're now saying is that we're calling the derivative of the function f of x with respect to the variable x is the function f prime, whose value at x is this guy. So f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now before we had x naughts in here instead of x. In other words, we were just finding the derivative at a specific point. So what we can now do is we can think of the derivative itself as a function. And it can be found for any value of x, and then later if you want the derivative of a specific value of x, you just plug it into that x once you've evaluated this guy. I also want to point out that the author starts using some other notation for this f prime of x. So this notation, dy, we say dy dx. It looks like a fraction, dy divided by dx. You just say it as dy dx. That's simply just another notation for f prime of x. It's just another way to write that. There will be a reason that we use that notation later, but for now, just think of it as another notation. Okay, so our next example, example 26, find the derivative of f of x equals the square root of x for x greater than 0. So the reason I'm showing you this example is sometimes the algebra becomes a little bit more intense, but it's always going to be a couple procedures that you need to do. You've already used this one before where you have to multiply above and below by a conjugate, so that's the technique whenever you see a square root type function. So remember, f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. So f of x plus h means take x plus h, stick it in for x. So it's the square root of x plus h minus the square root of x, f of x, all over h. So we have to be able to simplify this to get an h in a numerator to cancel out with an h in a denominator, and we're nowhere near that right now. So what the trick for here is when you have something like this, we got to get rid of some square roots in the numerator. The way to do that is to multiply that numerator by its conjugate, which just means change the sign here to a plus sign and then multiply. All these square roots will actually drop out, you'll see, when you do this FOIL. But you can't change the problem, so since you're multiplying the numerator by that, you also need to multiply the denominator by that. So it's essentially multiplying by 1. So when you simplify that, right, square root of x plus h times square root of x plus h is x plus h. Then you have minus square root of x times square root of x plus h, and you have plus square root of x times square root of x plus h. Those cancel. Then you have minus square root of x times square root of x gives you minus x. So really it's just x plus h minus x, which leaves me h in the numerator. The denominator doesn't simplify at all. You can't do anything other than you have h times that quantity. So h times the quantity, square root of x plus h plus square root of x. So, but it came out to what we wanted was to be able to cancel an h in the numerator with this h in the denominator. So then it's 1 over the square root of x plus h plus the square root of x. Now I'm just going to evaluate the limit by plugging in h equals 0. So I get 1 over the square root of x plus 0, or just square root of x, plus square root of x. So I get 1 over 2 square root of x. So that's the derivative. At 1 over 2 square root of x is the derivative of the function square root of x. In other words, stick any value of x in here and it's the slope of the tangent line to this function at that value of x. So what's the tangent line to the curve of y equals x square root of x at x equals 4? So first we need the slope. The slope, which we call m all the time, is at x equals 4. We want f prime of 4. So that just means here was f prime of x, 1 over 2 square root of x. So we plug in x of 4. 1 over 2 times square root of 4 simplifies to 1/4. The point we're looking at, the x naught, y naught, is x f of x. So it's 4f of 4, which is 4/2 after simplification. Here's a picture of it. Here's 4/2. We found the slope to be 1/4. So to actually find out that this line is 1/4 x plus 1, we plug it into the point slope form. Y minus your y naught is 2, equals m times x minus your x naught is 4. Do the simplification to put it in slope intercept form, you get y equals 1/4 x plus 1.